Good morning, panel. My name is Alastair and today I'll be presenting Digital Eye. This will be part of the Python and Linux course in Term 2. Problem statement. To design and build a compact mobile Raspberry Pi controlled object detector to digitally recognize physical objects in the real world, this technology aims to replace human surrounding surveillance and aid those who are visually impaired. Object detectors, or object detection, is a computer technology related to computer vision and image processing that deals with detecting instances of semantic objects of certain classes in digital images and videos. While research domains of object detection include facial detection and pedestrian detection. Research on existing technologies. I will be going through surveillance and security, analytics, and self-driving cars. Identify the possibilities. We've all seen a form of object or facial detection. Your phone. It tries to focus on your face for better photos. Cars are regularly equipped with similar systems to identify dangers while driving. This minimizes the human error whilst driving using emergency braking systems. Security networks are able to analyze suspicious activity in crowded places, such as airport analyzing suspects of human trafficking. After looking at other projects incorporating object detection, I figured that if a computer can detect and recognize objects, that's basically a simplified version of what we do subconsciously. That is, if you can see. Programming processes. Identify a problem. In this case, the eye for the blind. Analyze the possibilities and solutions to the scenario. Utilize a digital camera as an eye. Identify existing technologies that accomplish this task. Object detection in surveillance nowadays. Implement the technology. I used the Raspberry Pi and the camera to analyze. And perfect and troubleshoot to make the design. I troubleshooted the project. Aims. I wanted the device to be easy to use for the visually impaired. I also wanted it to be accurate with its audio cues and compact and mobile so that the user can go about their business in their household freely. Step number 1. Setting up the programs. Setting up the paths and directories. It is important that I make an environment in which to program in, to organize and isolate my program to a desired path. The first program that I integrated into my project was TensorFlow. It is a free and open source software library for data flow and differentiable programming across a range of tasks. It is a symbolic maths library and is also used for machine learning and applications such as neural networks. The second was OpenCV, a library of programming functions mainly aimed at real-time computer vision. Originally developed by Intel, it was later supported by Willow Garage and Etsys. The library is cross-platform and free to use under the open source BSD license. Combining TensorFlow with OpenCV. Getting a working program was very difficult, and this was definitely my biggest hurdle in the race to finish the project. Through hours of tutorials, revision of my terminal commands from Linux, and sequentially pathing programs, I finally had a working program for object detection. XML files are extensible markup language. These files contain the information that is used to differentiate between objects at any size. In computer text processing, a markup language is a system of annotating a document in a way that is syntactically distinguishable from the text. Meaning, when the document is processed for display, the markup language is not shown and is only used to format text. This is my structure model. The digital eye has hardware components of the Raspberry Pi on the wireless network, as well as a Pi cam connected with a power bank at 20,000 milliamps. The software component includes the program, which includes TensorFlow and OpenCV that are linked to an object library through an XML file to be read by the identification program. Audio cues. In order to relay the information to the user, the program has an audio module that tells the user what the object is in front of them. I hope to expand on the code further to give better instructions such as direction and distance. Before I play the clip, I wanted to just add that the program isn't perfect yet. I still have a lot of bugs in the system for misrepresenting certain objects, and you'll see that in the program. But I think that everything was successful otherwise.
TV, keyboard, person, chair, TV, bed, person, laptop, TV, bottle, fridge, TV, couch, person, bottle, oven, TV, fridge, table, fridge, bottle, fridge, laptop, bottle, TV, laptop, TV, bottle, fridge, oven, TV, oven, bottle.
Bill of materials. The components I used included 3D printing, the Raspberry Pi, the camera, the power supply when I was programming it, as well as the power bank that I used to use it when I was mobile. The prices turned out to be pretty expensive for the power bank, I would say, and the Pi camera, but otherwise I was expecting around about 1,000, 1,005 or so. So the price was about accurate. The difficulties I faced, the overwhelming amount of learning work I had to do for the object detection was surprising. There was a lot more that I had to understand before I could even start writing the program. The errors, I had lots of time to go through issues that I had problems with. Balancing responsibilities due to lockdown, you have all the time in the world to play around, but you have to work on your project. Obtaining components due to short supply of some stock. Managing processes, I was also struggling to get some things to work. Personal challenges, I'd say having to focus on something without the guidance that I would usually have, or being able to discuss with projects with other students before committing to one would have been nice. Lots of hardware issues. I didn't have the right power supply in the beginning. And keeping up with documentation was also quite difficult. But otherwise, I had lots of successes. Object detection works. The audio cues work. It's compact and portable. It's definitely upgradable. I will definitely be looking forward to improving the code and learn to work on my own efficiently. I would give myself a 6 out of 10 for time management. I had a lot of time to work on this, and yet I still found myself hours before the deadline scrambling to get a presentation done. I wanted a lot more with the project, though I struggled with certain features with the program. I decided to scrap the problematic features. I was hoping to get direction and distance into the instructions, but it just became a bit too noisy, and I didn't get it to work as well as I wanted to. Thank you very much, panel. And thank you for peers for watching. I'd like to say a special thanks to Lee, Richard, and JC for the past year and a half worth of guidance. Thank you for the awesome time at the college. Thank you to my peers Alex and Brandon and Vian for the good times and the distressing squash sessions. Though I had a term with you guys in the new group, thanks Liz, Josh, Jason, Raymond, and James for the engaging conversations. Here's our bibliography. Thank you very much, and goodbye.